Hello, good morning. Thanks for joining me here in my shop. And so we're going to be spending the video today, about a half an hour or so, reviewing the schematic for this radio. I'm going to be ordering a new vibrator for it, but in the meantime I figured out how to operate the radio without a vibrator, so I'll be able to continue with things like alignment and other circuit checks while we're waiting for the new vibrator to get here. And before doing those kinds of things, and maybe even changing out a few of these older capacitors that are still in here, it'd be smart for me to go through the schematic very carefully. And so I need to warn you before I start this, I haven't rehearsed in any way. I'm going to be looking at the schematic really for the first time in detail. So I'm bound to make mistakes, bound to say things and then correct them shortly afterwards. It's just the way it's going to go. But we'll generally work our way through the whole schematic and probably realize a few important things along the way. So here we go. Okay, so here's the schematic, and I can't quite get the whole thing on the screen. That's not bad right there. So we're going to start at the antenna end and just work our way all the way through it. And we've already talked a little bit about the power supply, but we're going to skip that for now. So let's start right where the signal comes in. Comes in on the antenna, goes through let's see, a coil and capacitor. Don't know for sure why they're there. And then this is an adjustable capacitor here. So some kind of trimmer on the antenna circuit. Let's see. Signal comes here, gets into this coil, which is also tuned, or adjustable rather. This is one of the slug tuning. And see the dotted line indicates that all these, here's another one here, slug tuned coil, these are all adjusted at the same time. So this, you can think of this dotted line as being connected to the tuning control that you turn on the front of the radio. When you turn it, you're actually moving these three things all at once. This one tunes the front end RF amplifier circuit here. This one tunes between the RF circuit and the start of the IF circuitry in here, the intermediate frequency circuitry. This last one down here is tuning the local oscillator. Look, it even says oscillator right there. So let's go back here. Let's see, the signal from the antenna, after making it through this tuned circuit, it must be tuning against this capacitor here, I think, which is going to ground. I think that's where the resonance is coming. This is fed into the grid of the tube. Oh, these tubes are showing upside down from today's standard. So we see the heaters are at the top, cathode is here, grids, quite a few grids in this tube, and then plate at the bottom. So what else can we see here? Suppressor grid. There's going to be a screen grid in here. I think it's that one right there. So it's 7A7. So the job of this tube is to take the antenna signal that's made it through this tuned coil and boost it up before it carries on into the radio. And what kind of boost do you get? Okay, so if I'm reading this exactly right, so I think take the signal on the antenna, and by the time you get to the grid of the first tube, so this is lined up with the grid here. By the time you get to the grid, you're almost 8 times stronger. Okay, okay, that's what it says. 8 times stronger at 600 kilohertz. So come through this tube, we come out the other side, and between the grid, the input of this tube, and the input of the next tube, there's an 18 times increase in the signal strength. It's the amplification of this tube. Okay, so signal comes out on the plate here. Got a little note there, 125 volts DC on the plate. And the signal Goes through this capacitor. This capacitor is blocking the high voltage on the plate here. There's high voltage on this line, blocking it from getting it on the other side and getting onto the grid here. So this is a critical capacitor. 100. How do they do their capacitors? Let's jump down here and see what it says here. All condensers are microfarad, so picofarad unless otherwise stated. So up here where it says 100, this is a 100 picofarad capacitor. It's a very, very small one, and it won't have been changed because the person who did the capacitor changes in the radio before it came to me has changed all the paper capacitors out, but he's left all the other ones in. And that's okay. There's no reason really to think this is defective. This type of capacitor, it's almost certainly a mica capacitor, and it's almost certainly still good. So we come down, here's another trimmer here. So you have a trimmer and a trimmer in here. This is the in-between stage, or the area in between the antenna amplifier, if I can call it that, and this converter, which is going to convert the antenna station frequency you're trying to tune to a fixed frequency for the well, that's a terrible way of saying it. Terrible way. I won't finish that statement. That was not very good. So let's go down here. So down here we see the gang tuning coming into here. You see what looks like this one must be a trimmer here. You can see the little arrow on it. It's an interesting arrangement here. This would blow my mind trying to sort all this out. I don't think I'm going to. Here's another trimmer here. And this capacitor is shown with a weird shape on it. I've never seen the symbol done like that. That says, I think that says, is it 550 or 350? Is there a key down here? Is there some hint as to what that means? Oh, I just found out how to work my computer. I don't see anything down here. Almost know how to work my computer. No, they don't explain what that symbol is. Is there any more of them like that? Maybe the draftsman's hand shook when he was drawing that part of it. There isn't another one in here. So this might be a temperature sensitive capacitor. C8. I don't think I have a parts list. Maybe there is one. But this could be a temperature sensitive capacitor, and really it's a temperature compensation for the radio getting hot and cold, and these parts literally expanding and contracting and changing their values. And I believe this is a compensatory capacitor, so we'll leave it at that. Wouldn't want to rush in and change this one without being very careful. And again, it's probably, it's a small capacitor, it's probably still in there. The original one's probably still in there. Okay, so this is going to oscillate because part of the signal is fed back into it. Let's see if we can spot that. So we can assume this is grid. Look at that, I'm not going to be able to sort that out. But this says G something, G0 it looks like. So this is one of the grids. So this is where the local oscillator is going to be fed in. And you can see from the antenna, not from the antenna, from the plate here, it's making it to a grid here. Is that a grid? No, that says screen. I'm sure that says screen. That says grid. Okay, well, I don't know what's going on. I warned you about this. So I think the signal is coming in and it's going in here from the antenna and the RF amplifier, and the local oscillator is coming up through here. Go in the two together and get mixed up. A part of the mix-up is extracted here through this capacitor back into here. So this is the feedback that gets this thing oscillating at a frequency controlled by the knob on the front of the radio here. and these trimmers, which are adjusting it and also changing the dial linearity so the pointer matches the numbers on the dial all the way across. So that's what these are. Okay, moving on. I'll be adjusting this stuff when I go to do the alignment. That's the thing. So what other interesting things can we find out here? Let's follow the cathode back here. Cathode. Where's it going? So all the way back to this one. Oh. This is an interesting arrangement. What's going on here? This is like a volume control or something like that. This is unusual. So let's say we got a chassis ground here, and what we're doing is we're changing the resistance into the ground from the cathode of these two tubes. Now this looks like this would be a technique for developing bias. The variable here. Well, you really got me on just what this is. 0 to 800 ohms. Well, if this is, you know, this could be the volume control. I don't know. Quickly, let's jump way down here. Is there a volume control down here? Right here. So here's the volume control. Here's the tone control. Down in the audio part, the non-radio part of this, the audio part. Okay, well, I don't know what this is. Maybe it's a one-time adjustment to set the bias or bias floor. These tubes usually are controlled, their gain is controlled by AVC. Okay, let's just keep this in mind and carry on. And when we get to the AVC, we'll end up back here again. So at this point, we've got the signals coming into the converter. So that amounts to basically two signals, local oscillator signal and the antenna. The antenna signal, of course, is a mess of stuff. All kinds of stuff is reaching this tube. They get mixed together in the tube due to non-linear characteristics of how this tube is operated, and out comes not only the original antenna signals, all of them, and the local oscillator comes out, but also what comes out is the difference frequency and the sum frequency of all that stuff. Okay, so I'm not going to explain that any further. Suffice it to say, this part of the radio only tunes one thing. I think it was 260. What did I see the note for? 265. What was it? Somewhere. There it is. Yeah, 265. So this part of the radio is fixed tuned all the way through here to 265. So anything that arrives on the plate, which is a local oscillator and all the signals from the antenna and the sum and the difference of those, all arrive here. The only signal that'll carry on is anything that's at 265. So we turn the tuning dial, change the local oscillator, change the sum and difference frequencies. If any one of them hit 265, they come flying out of the speaker down here. Let's carry on now. So the signal comes out. We'll just pay attention now to only the IF 265. It's going to come through here. This will be tuned. This will be tuned by capacitors here. That's great. Okay, I prefer that to try to tuning a slug in these coils for lots of reasons. The signal reaches the grid of this tube, comes out on the plate here, and so this is the IF tube. So this is just boosting the signal between this transformer and this one here at 265, and now it's coming into here. What is this? Well, what is this thing? Looks like some kind of super multi-plate capacitor or something like that. Is that what this is supposed to be? There's nothing else like it in the radio, eh? Look at this thing. And they seem to be This looks like it's got a, like there's an arrow here indicating it's adjustable. Well, you know, you adjust this trimmer capacitor to tune this to the 265. Must be same thing going on. That would be this upper part. And this is kind of weird. And I got this coming up here and going there. Well, that's a mysterious thing, but I believe it's just some kind of fancy capacitor thing going on there. Okay, so we'll carry on. So the signal is now coming out of here at 265 kilohertz, fed into, ooh, this is hard to look at. Well, let's see, grid, plate, heater, cathode, diode. So this is a two-part tube. It's like having two tubes in one. One part is just a rectifier diode, right there. And there's two of them in here. They're just connected together and used as one. So the output from this transformer is fed into a diode to rectify it. So the result of that is a buildup of DC voltage. It's going to build up in here. You'll be able to pull it out of here. Hey, there's no values on these resistors. Yeah, 15 meg, 15 M. M means K. By the way, M means 1,000 on this older schematic. Okay, there's something going on here too. Brown. Let's follow this line. It's down here. Goes here, meets a big resistor, and here's a fair size capacitor, 0.05. And let me guess, this goes all the way up to grids. Through here, the DC can get through the winding and right onto a grid. Let's follow this one up. Through a big resistor, through this coil and onto a grid, and then the last one, guess where it goes? Anybody guess? Onto a grid. So that's the AVC line here. It takes the buildup of DC voltage in the detector and utilizes it. Kind of like the way vacuum systems on cars operate. Cars create a vacuum, at least they used to. I don't know if they still do, to be honest with you, but carburetor cars created a vacuum, and clever engine designers began to utilize the vacuum. It's not there to, well, for instance, my friend had a 1960 Ford Galaxy 500, and it used vacuum to drive the windshield wipers. Can you believe that? And it was the strangest thing. If you're going down the highway, this is the strangest thing, and you're in a rainstorm, so you got your windshield wipers going, and you decide you want to pass the car ahead, which you shouldn't really do in a rainstorm with your windshield wipers going. But let's say you did, because after all, we were 16. I'm not driving. My buddy would step on the gas really hard, the vacuum disappears in the engine, and the windshield wipers stop. That's why windshield wipers are no longer run by vacuum. But the point is, the DC that develops in the detector is an accidental opportunity to use the DC to control the grid voltages back here, and these tubes are designed in such a way that raising and lowering the grid potential changes the gain of these tubes. So that's how the automatic volume system works here. Now if you're going to hook up to a grid, grids are inevitably very high impedance, or usually very high impedance circuits, and the diode out here, this is very low impedance. So what they're doing is they're raising or protecting the impedances down here with this big resistor here. Whoops, this big resistor. So when it comes to testing a radio, you can hook up an instrument on this side of this big resistor. Yeah, you see this resistor is inside the can. You can't even get at it. So you could hook up here and not affect the radio very much. And if you hook up your meter, scope, whatever over here, you're probably going to knock the radio right out. because the impedance is very high. In other words, it doesn't take much charge exchange on this wire to change the potential of it. Okay, now moving back this way. So along with this DC voltage coming out of the detector, down here, there can also be audio. So here's a ground. So see that this circuit is kind of flipped upside down from how it's shown in most radios. In most radios, this volume control resistor is pictured in such a way, in most schematics I should say, so the grounded end is down here. This one's reversed. The grounded end is shown the other way around, and the signal is coming in from the bottom, which is just not what you kind of expect at first. Volume control 250K. It has a kind of a backdoor deal here. But this is the slider, this thing here. So you're tapping off some of the audio signal here. There's some DC here too, coming back from this DC charge, leaking through here. So to block that DC from going any further, there's a capacitor here. If this capacitor is shot, the audio has a hard time getting through here. Look at, they got a gigantic resistor here, 15 megohms. So you know this is going to be high impedance here. They wouldn't use 15 and onto a grid. So see, basically the rectified signal comes out of this tube. Remember, this is a two-part tube here. It's two tubes in one. So the first part, the diode, produces the DC and the audio works its way back into the same tube again to go through the other half of the tube. So why did they do that? Well, because you only need one socket now in your radio. You only need space for one tube in your radio. Radio designers love this multi-purpose tube design here. Well, loved it? I don't know. They certainly utilized it. So now, after going back into this tube, it meets up with a triode, just an amplifier, gets amplified and shot out here on the plate. So out of here is coming now some stronger audio. And you've really left the world of the radio. The higher frequency, RF, all that stuff is gone. Here it's just audio. So let's see where it goes from here. It's interesting. Just look at this. Ooh, this is hard to look at. What have you done here, Mr. Drafter? So this tone control for sure. You kind of got me on exactly how this works, so I'm not going to kill myself trying to sort this out. I'll probably get it wrong anyway, but you know, needless to say, here's a tone control. A couple things about tone controls. The simplest tone control is a treble cut. You basically have just a variable resistor and a capacitor, and you're just dumping the high frequencies out of the radio. And beyond that point where the control is, there's just not as much high frequency stuff. That's a lot of radios work that way. Very, very common. Some the designers get a little more clever, and and I don't think that's what's happening in this radio, but they can get more clever. As they get more clever, these controls and the networks of capacitors and resistors get more and more complicated in here. So it's not unusual to get to this point in the radio and find the tone control and perhaps even the volume control is kind of mixed in with a whole bunch of capacitors and resistors and all kinds of stuff, because the radio designers were trying to smooth things out, so to speak, and other stuff, trying to get everything just to work right. Probably a lot of experimenting went on in radio design right in this area. And you know what you listen to, right? You listen to the speaker. You're not listening to this tube here. You're listening to the speaker and the signal that's fed to it. And this is what the designers need to really concentrate on, is controlling the sound that comes out of the speaker, of course. So sometimes these get really, really complicated in here. That's enough of a speech. So now if we follow the signal, it comes out of the detector triode. Another blocking capacitor here, another important capacitor. This one is a 0.01. So this one's probably been changed. It's a bigger capacitor. It was almost certainly a paper capacitor. So this one's almost certainly been changed out. That's really important, because if this is, even if this is kind of okay but leaking a little bit, it will leak some charge into this high impedance circuit here, and a little bit of charge will go a long ways towards changing the potential and affecting the grid. And what happens here, unfortunately, is you push the grid more and more positive, more and more current flows through this output tube, and in the worst case, with the radio still sounding okay, this thing can be conducting so much current it's overheating, and it'll wear it out, burn it out, who knows. So this is very important capacitor here, okay? And now, so we have the sound going into the last tube here. Anything special about this guy? What's going on in there? So it looks like that structure there is hooked up to the cathode, so I think that's supposed to represent a suppressor. Oh, you know what? This is probably a beam power tube, and this is probably representing the beaming part, how they channel the electrons in a beam power tube. That's probably what that represents. Okay, how is this one now? The output tube 2, it's along with this capacitor affecting the potential of the grid, there's another thing that affects the potential of the grid, and that's this resistor here, which is in the cathode circuit. Essentially what this is doing is it's because of the voltage drop here, it's raising the potential of the cathode up towards the plate, maybe 10 volts. So between the plate and the cathode you've got 300 volts or 250 volts, and you're going to throw 10 of it away on this resistor and move this cathode up in voltage. Now the reason for doing this is because it leaves the grid behind. The grid remains zero. I hate to say zero, but we can say that. The grid remains zero. The cathode has now been made somewhat positive because of this resistor. The result is the grid is now negative relative to the cathode, and there's your bias. These resistors take a beating in radios. For instance, if this capacitor leaks and more current flows through, this guy carries more and more current. He gets hotter and hotter. It's a hard working resistor here. These things often go high, and they go from 270 to say 500 ohms. That pushes the grid potential way negative, assuming this guy's not leaking. It goes way negative, and the tube quiets down. Can't produce as much volume as it used to. And of course, in the worst case, this will go right open. That can happen. So we have to find this resistor and check it for sure while we're in there. Now let's carry on. Okay, so here's the signal coming out on the plate. It's full strength now. It's got some power to it. The plate is run at a high voltage. It's going to be fed from this power supply down here in such a way it's getting the highest voltage they can muster in the radio, I think. 215. This is 215. Any other voltages written along here? 195. Not much different, is it? But they want max out the voltage on the plate, make the heaviest, make this tube work the hardest. Output signal now fed through this transformer and comes out the other side of the transformer, and it should basically go straight to the speaker, but they're gonna show it coming down here. This is the speaker. This is the speaker plug that I thought was miswired, but apparently isn't. And what's called a field coil. Field coil. Huh. Okay, so we gotta stop the presses right here. Now the speaker I've got with this radio is a brand new radio, only contains a voice coil. It has a permanent magnet, but this diagram is for a different kind of speaker, an older one without a permanent magnet. A little surprised to find this here actually. And that means that this field coil is usually part of the power supply. Wow, would we be able to track that back? Let's see. So the field coil is sharing a wire with the voice coil right here. That's not the best thing either. Oh my gosh. Would we be able to figure that out? What they're doing here? Okay, let's try the other wire. This wire comes down this side. So it's this one. This other wire, it really looks like it hooks up to the shield here. This dotted stuff is a shield on the wire. Looks like it's hooked up here to this pin. Okay, and then the last wire is the field wire, which is coming down here. Okay, so now we'll pretend this is plugged in here. Oh my gosh. So this center piece is actually hooked up to here. It's just going to go to ground. This other piece here, this one, it's really important to figure this out, by the way. Voice coil. So this is voice. This last one must be going up to the field coil. It's really important to sort this out. Field coil. Okay, so when I look at this radio, and I look at the plug in the speaker plug, we won't look at it right now, but when I look at it, what I see is the voice coil of the speaker we're using is hooked up between this point and this point. Yikes! Now, there's a really good chance oh, it says right here, prong view of speaker plug. Okay, well that explains it then, because I think that explains it. Because I was looking at the plug from the back side, but you have to look at it from the prong side to see this. Okay, so what I'm seeing then in the radio is the field coil is just connected to nothing. The field coil leads are connected to nothing on this plug. This terminal is just hooked up to nothing. And the other two are hooked up to the voice coil of the speaker we're using. It explains why the whole thing works. I mean, the radio works. So what's happened now? We'll get down to the power supply. Perfect. So as I mentioned, this field coil is often used as part of the power supply. Can we see that here? Okay. Well, let's go through the whole power supply. Wow. Start right back here. So here's the power coming in from the car battery, going through a fuse, 10 amp. Then we've got this rather odd looking capacitor here, and I think I know what these look like on the radio. This is actually a small plate bolted up against the side of the chassis with some kind of dielectric material in there, actually using part of the chassis as a capacitor. In fact, in the radio I'm looking at, there's two. There's another one, but maybe this doesn't exact. Oh, here's one. This looks like another one here. See, 26 and 25. So those are probably the two chassis plate capacitors, I guess I can call them. Okay, let's keep going. Connection to the chassis through a capacitor. Okay, we come up here, 12 volts here. Now it goes in two directions. Let's see, let's go this way. So you go through this low resistance, a big coil, big fat coil, capacitor, coil and capacitor, some kind of filter arrangement. Maybe filtering out spark noise from the engine. Up here, you got your 12 volts, hits a 55 light. 55? No, 6 volts, 6 volts, 6 volts. It's a 6 volt system. So ignore everything I said about 12, it's 6. Yeah, a 55 is a 6 volt light. And it carries on off to the heaters and speaker field. So in this case, it looks like, Well, that's kind of interesting, because the radio is being fed with DC from the start. The designers have an opportunity to utilize the DC right from the car battery to do stuff. And in one case, they're sending that 6 volts DC stuff right through the speaker field. But it's not part of the filtration of the high voltage power supply as it commonly is. So in this radio, if you just ignore this, you just don't hook a wire up, you just don't send a wire to the non-existent field coil, nothing will happen. In fact, if anything, you've lightened the load. Well, you've lightened the load on the car battery, but not by much. Okay, that's fine. So everything's good. And check this out. I kind of haven't really said this, but look, wiring view of foot switch socket. Yeah, there you can get a foot switch. And so this is muting and station change switch. So you have a foot switch. You could touch it. You could, I guess, cut the sound off on the radio, so you could talk to your wife or whatever. Or push it. I guess maybe this is goes in 2 directions. Push it, and the radio will tune automatically to the next station. Wouldn't that impress your friends? They wouldn't even see you move your foot. You could do like a ta-da thing. You could say, you could even talk to your radio and really fool your friends. Radio, tune to CFRB. You quietly push that button on the floor with your foot. Your radio would tune. Wouldn't that freak everybody out in 1947? My God, he's talking to his radio. But not today, right? We do talk to stuff today. Mind you, the stuff we talk to never understands what we're saying, but we still talk to it. Okay. Like my friend Siri. Okay, now we'll do the power supply. Go the other way here. So 12 volts coming through another very low resistance and big fat coil here. Capacitor of some size, 0.5 microfarad. This has probably been changed. It's probably a paper one. It's already been changed. And now far be it from me to explain this in great detail, but at a higher level, here's the vibrator, and what it's doing is it's shooting the 12 volt current alternately into this winding, whoops, and then into this winding. You see it's coming this way at one point, coming the other way at the next point, and this transforms over here. This is no doubt a step-up transformer. Look, 0.08 ohms, 307 ohms, so it gives you an idea. The winding ratio here is huge. And out of here comes a pretty high voltage, but it is really, really messy, because this thing is messy. This is a messy deal. So what I mean by that is all kinds of harmonics and unwanted frequencies are coming through here. So this capacitor's job is to nip them in the bud, cut them off, eliminate them, drain them out before, should I say filter? I guess I could say that. Smooth this guy out a little bit before. I shouldn't say smooth that out. That's a bad term. No smoothing here. No smoothing yet. So then that alternating power is sent to these plates in the rectifier, and ultimately a positive voltage develops on the cathode of 225 volts, which is then fed up into the radio, meets up with this filter here. So this filter, 10 microfarads, 20 microfarads. Okay, so I guess this refers to here, and then this one refers to this piece. So you put a 20 microfarad capacitor, probably one of those paper ones we were looking at, in fact. You know what, those 2 paper ones that were left behind in the high voltage power supply area, probably this right here, these 2 right here. So one of them's job is to smooth out the power going to the plate of the output tube, and the other one is to smooth out all the rest that's going to screen grids, going to plates, going probably everywhere in this radio. Yeah, that's what it's doing. It's going to all these plates here. So that's its job. So either one of these not working well, you would hear some kind of a hummy, buzzy sound, I think. Wouldn't be quite the same warm hum you get in a regular plug-it-in-the-wall radio. This one might, because of the way this operates and the frequencies involved, I'm not sure what you would hear exactly, but some hummy, buzzy sort of sound. It's quite likely these guys are not up to snuff anymore. Although when we played the radio, it sounded pretty good. Could be the last guy, after doing the paper capacitors, played the radio and was satisfied with it at that point, and so he decided to leave these guys in there. Why don't we take a look at some of this stuff? I've reached the end of the road here anyway. There's no more to talk about, except what about this? What about this? Let's take a look at this now. Tone control, volume control, on off, indicator window. Now on the radio we're working on, this just sits on M for manual. It's just stuck there all the time. Station selector touch bar. There is no left and right, up or down. It's just, this would be the driver's part and this would be the passenger's part to push. Man, you know, I could have just made that one long bar, right? But maybe they wanted to say, and look, there's controls, separate controls for the driver and the passenger. Buy this car. Adjust intended trimmer through shaft of hole after removing knob. The reason they do this is, I can tune up this radio on my bench, but one thing I can't do is I can't imitate its existence in the car where it's eventually going to live. So putting in the car, hooking up the car antenna, the wiring, the antenna, everything is going to have an effect here. So almost certainly this is the capacitor that you're adjusting through a little hole behind this knob. There, see, they're showing it right there. There's the screw. So you pull this knob off and there's a screw. So you sit in the car, tune in your favorite station, turn that screw until it's as loud as you want. Maybe check the rest of it, make sure you haven't quieted other parts of the band that you might be interested in. If you are, and put the knob back on, you're done. So that part I can't do really here in the shop. I can't do it properly, but it's easy to do. So I think we have hit the end of the road here. So we're going to peek at the radio for a couple of minutes, and then I'm going outside because it's another fantastic day here. It's just fantastic. Okay, back to the radio now. Okay, so just a couple things about the radio. So yeah, so this is the big magnet. Obviously on this modern speaker there are no field coils on speakers. There haven't been for a long time. So the two capacitors in the power supply that we're just talking about are these two guys. There's another one down here. The big coils that filter the power on the way into the radio. One of them, can you see that? Can you kind of see that? No, not really, Jim. Okay, let's try this. Hey, what's with my camera here? There we go. There's those two big capacitors. Can we see the size on them? I don't think so. I don't think the 20 means 20 microfarads. Okay, there's another one down here too. Well, you can see that one. I think it says 15. Is that what that? No, it says 0.5. 0.5. So we can identify that one. But here's the coil I wanted to show you. Hold still for a minute. See the heavy wire coiled around what is actually the fuse holder. They just utilized it as a form and a handy. I mean, this is where they need it, right at the fuse. And then those weird capacitors, I think, are these things here, which look to be in pretty crappy condition. Again, this is some kind of trick. It's a trick. If one of these guys shorted out, you would just pop the fuse all the time in this radio. over here is a this is a capacitor that's been left behind. This is the mica type, and there's probably quite a few of them in here. You should be okay. By the way, see that black that black guy right there? He should have been changed. So that's a paper capacitor hiding under a plastic shell. And some of these are known to be terrible capacitors. I'm not saying this one is, but that's, you know, if you're going to take the time to change all the paper wax capacitors, you need to change these ones too, or you're not doing what you think you're doing. Any more of those in here? Here's these little, no, these are the big resistors. It's the other radio that has a little resistors installed there, with the capacitor miswired and loose. Okay, so let me just make sure I'm looking the whole radio over here. Another capacitor. See how they kind of like tucked down in there. Lots of these squarish mica capacitors, lots and lots of them. Sangamo. Buried, hidden away in there. I don't see any others. So it looks like there's one. Funny, why would they build this radio and have just one capacitor? A molded type. Is it really a capacitor? Or maybe he changed out the other molded ones. Maybe I'm assuming something here. Well, it doesn't look cracked, but I think that really should go. It's kind of buried under here, isn't it? He had a good opportunity to do it. If he was changing out the molded ones that were in here, he would have changed that one, because look, he did this orange one right here. I mean, your eyeball just has to fall a little bit to see it. So I suspect he just didn't realize it. So what this suggests to me is the fellow who did this work knew a little bit about what he was doing and knew enough to change the paper capacitors, but he may have just shotgunned them, and that means you just get in there and change them all, turn the radio on, and pray it works. Okay, that's enough looking around, I think, in here. So what we are ready to do now is the alignment process. Even though I won't have the proper power supply running, I can operate the radio successfully using the power supply up here, and I can carry on, do the alignment, and get the radio tuned up properly and ready to go. In the course of doing that, I might find a few more problems in it, but somehow I don't think so. I think it's really in actually pretty good operating state. A little bit of tune-up. Again, if the fellow who did this before was a person who knows about wax capacitors, and that's his target, is the wax capacitors, probably got scared off by these guys, then he probably didn't have the equipment to do an alignment. And so he may have made an attempt. Oh, that's too bad. Hopefully not. Or he may have just left it all alone. In either case, there's the potential here to get a performance improvement of some significance by aligning this radio. So that's what's going to happen tomorrow. For the rest of today, I'm going outside. That's where I'm going. Thanks a lot for watching. I hope you got something out of that, and I'll see you on the next video.